Welcome back to my math YouTube channel. For this video, I will discuss the interval estimates of population proportions, one of the topics in statistics and probability for senior high school. Every election, we see articles in the newspapers or we hear a newscast from televisions state confidence in terms of proportion or percentage of possible winning of a particular candidate. There are systematic procedures to address the above concerns. One of those is the interval estimates of population proportions that will be discussed in this video lesson. The shorter formula for computing a large sample confidence interval for a population proportion P is P hat plus or minus Z alpha over 2 square root of P hat times Q hat all over N. Let's take up now our first problem. A survey of 1,200 citizens randomly selected showed that 745 trust the president. Compute the 95% confidence interval for the proportion of all citizens who trust the president. Once again, this problem is very popular, particularly if the election is fast approaching. Let us solve now the confidence interval. Let us understand the problem by enumerating the given. X is equal to 745, showing trust to the president, and refer to the number of size, which is equivalent to 1,200. The confidence interval required is 95%. Its Z alpha over 2 or its value from the Z table is 1.96. Again, identify the given correctly not to commit mistakes on the process. Start solving by identifying the p hat whose formula is x over n. Substituting x to 745 over n, which is 1,200. Continue by simplifying 745 divided by 1,200. Its quotient is 0.621 rounded off. So the p hat is equal to 0.621. Next, solve for the value of q hat using the formula 1 minus p hat. Substituting p hat to 0.621, 1 minus 0.621 equals 0.379, and that is now the value of q hat. Since we have now p hat which is equivalent to 0.621 and q hat which is equivalent to 0.379, we are now ready to solve for the maximum error. E is equal to Z alpha over 2 square root of P hat times Q hat over N. Substituting the values on the formula, Z alpha over 2 is equal to 1.96, P hat and Q hat are 0.621 and 0.379 respectively, N or the sample size is 1,200. Simplify first the numerator inside the radical symbol. 0.621 multiplied to 0.379 is equal to 0.235359. Dividing its result to the number of sample size, which is 1,200, its quotient is 0.000196. Continue. Multiply square root of 0.000196 to 1.96. Its product is 0.027, and that is now the margin of error for this particular problem. On the formula, it means that the margin of error will be subtracted to the left side and to be added to the right side of the proportion expression to determine the interval estimates. To continue, substitute the value of p hat which is equivalent to 0.621 to both sides of the population expression and subtract the minimum error 0.27 to the left and add it to the right. Simplifying the left side, we have 0.621 minus 0.27 equals 0.594. Simplifying the right side, 0.621 plus 0.027 equals 0.648. By that, we can now say that the estimate interval for P is between 0.594 and 0.648, which can be converted into 59.4% to 64.8%. Once again, to change decimal to percent, just move the decimal 2 places to the right and annex a percent sign. Therefore, with 95% confidence, we can say that the interval from 59.4% to 64.8% contains the true percentage of all citizens who trust the President.
Magaling mo pala dyan ah. Hindi ko alam ah.
Another one.
For our next problem, in survey of 548 random households, people take pride of discussing their methods of environmental protection. 326 manage their trash by separating biodegradable, which are converted into fertilizers, while non-biodegradables are disposed properly. Use a 90% confidence to estimate the proportion of all households who have good practice of trash management. To enumerate the given, X, who represent all households who have practiced good trash management, is 326. The sample size, or N, is equal to 548. The confidence interval is 90%, whose Z alpha over 2 value from Z table is 1.65. To solve P hat using the formula X over N, we have 326 over 548. If divided, we have 0.595. So our P hat is 0.595. Next to solve is the value of Q hat by its formula 1 minus P hat. Substituting the value of P hat, which is 0.595. So we have 1 minus 0.595. Its difference is 0.405, and that is now the value of Q hat. Just because we have now the value of P hat, which is 0.595, and Q hat, which is equivalent to 0.405, we are now ready to solve for the maximum error of the given problem. Substituting the given data on the formula, we have E is equal to 1.65 to the square root of 0.595 times 0.05 over 548. Simplify first the numerator inside the radical sign. 0.595 times 0.405, its product is 0.24975. Divided by 548, its quotient is 0.000397. Next, multiply 1.65 by square root of 0.00397. Its product is 0.033. And that is the maximum and minimum error. After solving the maximum error, we are now ready to solve for the interval estimates. What we will do next is we will subtract 0.033 to the left side to get the lower limit, and we will add 0.033 to the right side in order to get the upper limit. 0.595 minus 0.033 is equal to 0.562. To the right side, 0.595 plus 0.033 is equal to 0.628. And finally, convert the decimals into percent by multiplying both sides by 100, or simply move the decimal 2 places to the right and affix the percent sign. So we have 56.2% to 62.8% is our interval estimates. Thus, with 90% confidence, we can say that the interval from 56.2% to 62.8% contains the true proportion of all households who practice good trash management.
Ang galing mo pala dyan Hindi ko alam
Dalawang beses na yan! But wait! There's more!
Let's proceed to the third and last problem for this video. In a certain school canteen, 287 out of 620 randomly selected students indicate their preference on the new kind of food combination offered by the canteen. Use a 99% confidence to estimate the true proportion of students who like the new food combination. Again, for our given, the X value is equal to 287, sample size is 620, the confidence level to be used is 99%, whose equivalent Z alpha over 2 is 2.58. Again, first to solve is P hat, whose formula is X over N. By substitution, we have 287 over 620. Simplify 287 divided by 620. Its quotient is 0.463, which is the value of P hat. Next, solve Q hat by its formula 1 minus P hat. By substitution, we have Q equals 1 minus 0.463. Simplify by subtracting 1 and 0.463. Its difference is 0.537. Since we have now the value of P hat and Q hat, which are 0.463 and 0.537 respectively, we are now ready to solve for the possible maximum error of the given problem using the same formula above. Substituting the values on the formula, we have E equals 2.58 multiplied to the square root of 0.463 times 0.537 all over 620. To solve, simplify first the numerator inside the radical sign. 0.463 times 0.537 equals 0.248631. Continue simplifying inside the radical sign. 0.248631 divided by 620. Its quotient is 0.000401. And finally, to solve for the maximum error, multiply that result to 2.58. Its product is 0.052, representing the maximum error for this given problem. To get the interval estimates of the given proportion, we have the modified formula. P is between P hat minus minimum error and P hat plus maximum error. To proceed, substitute the value of P hat, which is 0.463, to the left and right of the expression. Also, substitute the value of error. Subtract 0.052 to the left, add the same to the right. Subtracting the right side, we have 0.463 minus 0.052 is equal to 0.411. Adding the right side for 0.463 plus 0.052, the sum is 0.515. Initially, we can say that the interval estimates for population P is between 0.411 and 0.515. Or, in converting it to percent, we can say that it is 41.1% to 51.5%. Thus, with 99% confidence, we can say that the interval from 41.1% to 51.5% contains the true proportion of all students who like the new food combination offered by the canteen.